Hello everybody, today I'm going to be talking about solutions of quadratics and making the connection between solutions of quadratics and graphing quadratics. So let's remind ourselves about what a quadratic function is and how it is represented. A quadratic function is a function that can be written in the standard form of y equals ax squared plus bx plus c, where the value of a cannot equal 0. We can also write this y as function notation f of x equals ax squared plus bx plus c. Remember, what makes this a quadratic is that highest exponent of 2, often called the degree. So this has a degree of 2 or highest exponent of 2. This is going to help us not only be able to recognize what type of function it is, but it will also help us to know what shape the graph will take, and also it will help us to determine the number of solutions. Now, before we get into number of solutions, let's talk about quadratic solutions in general. So quadratic solutions by definition here are the points at which the parabola intersects the x-axis. Now that definition might sound familiar. You've definitely heard this definition before. This definition sounds very familiar because it is what we call the X-intercepts. Right? So these X-intercepts, also known as solutions to the function, are specifically on a graph the points where the parabola intersects the x-axis. Now remember, the other thing we know about x-intercepts is we know that with an x-intercept, the y value is always 0. So these solutions are also going to be known as the value of x when y equals 0. So that is why sometimes these are called the zeros of the functions. We will sometimes also be using square roots to help us find these solutions. Another name for solutions to a function could be called the roots. So 4 different names to represent the same exact thing, right? So let's talk real quick though, specifically about a quadratic. When you're talking about a quadratic, there is a specific number of solutions that can occur when you solve. Like, for example, if you were to solve something that were linear, like y equals mx plus b, if you were to graph that, it would be a line. A line can only intersect the x-axis in one place, therefore only having one solution. The other way I know I have one solution is that the highest exponent on x is a 1. So when it comes to a quadratic can have either 2 solutions, it can have 1 solution, it could have 0 or no solutions. This is something that I've talked about before when we talked about graphing, and I introduced to you the idea of x-intercepts in a quadratic. So let's talk about what that would look like graphically on these quick little sketches. So on a sketch, if you were to graph something with 2 solutions, that would mean that your parabola would cross the x-axis once and then twice, creating a solution here and a solution here. Again, those would be points where the y value is 0. One solution would be something that approaches the x-axis and sort of touches it, and then comes right back down. Something that looks like that. No solutions is what you might want to call a floating parabola, where it never ever crosses the x-axis. So those are the number of solutions that you can obtain. So now let's look at a couple of examples here. So I'm going to switch over here. Let's look at a couple of examples. So I have 4 examples here of different quadratic equations. So you can see they are quadratics because the highest exponent is a 2. You can also see that they are written in standard form, set equal to y. If I go to graph this first one, we can zoom in here a little bit. I can see that on my graph, I have a point here at 0, 0, and I have a point here at 2, 0. These are your x-intercepts. So if you were to solve this, meaning let y be 0, you would get 0 and 2. Let's check out the next one. This one also has 2 solutions. You can see the x-intercepts here at -2, 0 and 2, 0. So if y is 0, the x values are -2 and 2. The next one here, you can see here on this problem that our parabola only touches the x-axis in one place, and so therefore when y is 0, the x value is 1. So this is an example where there is one solution for x. And then the last one here, this problem here, you can see has no solutions because it does not cross the x-axis. Now, it doesn't mean that there are no solutions at all. There are what we call no real solutions. And when you get to higher levels of mathematics, you will learn ways to solve for what they call an imaginary solution. But for right now, in the idea of Algebra 1, we're just going to keep it with no solution, or you can even say no real solution. Okay, so those are just some examples. So basically, when you're given a graph of a quadratic, you're just to solve it for x, you're just going to look at the x-intercepts and specifically the x value of the x-intercept. So remember that a solution to an equation, even if it's a quadratic equation, will always be the value, or you can say values, of x that makes the equation true. So if we're looking at the equation from the Desmos example of y equals x squared minus 2x, we saw that the x-intercepts were an x value of 0 and an x value of 2. So in looking at the values here, we can know that if y is 0, we know that x could equal 0 or x could equal 2. And oftentimes we just write that answer as x can be 0 or it can be 2. We don't usually put the or, you can just write a comma. And so we're going to talk about different ways that we can solve this other than graphing as we go through each of these days' lessons. And depending on, your situation and what resources you have to involved in, and depending on what resources you have available to you, will often depend on how you solve the problem or how the problem looks. Okay. Sometimes the way the problem looks will also determine how you choose to solve it. Like, for example, if I don't have a graphing calculator and somebody wants me to solve one of these, I might not graph it by hand. I might try to solve it another method. So the solutions of a quadratic are the x-intercepts. The x-intercepts are values of x when y equals 0. So hold on for the next video where we'll talk about how you solve these using other methods other than just graphing. So I hope you enjoyed this video and good luck with your practice.